Hey guys, welcome and thank you for joining. This is the Oracle Autonomous Database Learning Lounge. I'm Marco Senasibia, part of the product management team for Autonomous Database. And today we're going to have a very cool session on maps with apps, right? So basically a database-driven development with Oracle Spatial using Autonomous Database. All right, so to begin with, I'm going to start with the agenda for today. So for the agenda today, we have David Lapp. He's a senior principal product manager in the database team, and he works with Spatial. So he's going to explain to us all, how location is an essential component, right, of any modern business application. And he's going to show us in both operational and analytic scenarios, right, how that works. But also location is key. So understanding relationship between businesses, right, and entities, areas, and things like that, demographics, traffic patterns, all these things. Um, he's also going to talk about then the special features in Autonomous Database and show how that you can work with it, in a programmatic way and also in a no-code way as well, right? So there's the Oracle Spatial Studio. Throughout the session, we're going to have an open Q&A. So if you guys have any questions at any time, we have Hans Wienmann, we have Jayant Sharma, we have Kit Laker as well on the call. So any kinds of questions you guys might have, please make sure to type them in the Q&A in Zoom, okay? And we're going to post some links in chat for you guys. And the recording is going to be made available a few days, probably by the end of the week. I imagine I'm going to be able to do that for you guys, okay? So before we start, I just wanted to highlight a few important links for you guys to bookmark. If you have interest on learning more about Autonomous Database, there are many, many interesting links. I'm going to paste them in the chat, okay? For you guys, I'm typing these same links in the chat so you guys can see. So without further ado, I'm going to stop sharing my screen and I'm going to let you share your screen. Thank you very much, David, for joining us today. And take it away.
Thank you for that introduction, and the poll was really helpful for sure, just to kind of understand where people are coming from. Okay, so yeah, I'm David Lapp, product manager on the Spatial team. And as Marco said, I'm glad to be joined today by several of my colleagues, Giant, Keith, Hans, who are all going to be available to answer questions. So please keep those questions coming, and really hope that this piques your interest in all the cool stuff you can do with Spatial in Autonomous Database. So I want to just begin by providing a little bit of context and sort of the driving principles behind what we do with Spatial at Oracle. First of all, I want to mention that Spatial has been a capability of the Oracle database for decades. Oracle Spatial has been a mature sort of enterprise-ready technology actually since the 8i days and began, even before that. And so now when we're at the point where we've got these mature capabilities within Autonomous Database, this has been around for a long time and is really developed over time and is, true, it's tried and tested. So this is not a new thing for us. This is a very mature, long-standing thing for us, and we've really grown tremendously over the years. But it's all began with and continues to be anchored on the fact that everything happens somewhere. So we've always looked at enterprise business data, whether it's transactional data or sort of historical data, data warehouse for analytics, et cetera. It can all be tied, or almost always be tied in some way, to location. Everything happens somewhere. So incidents, events, activities, transactions, it's all generally tied to location. And location, in many cases, really forms the sort of the integrating aspect of otherwise disparate data. So we start from that premise that everything happens somewhere. And then as a feature of the Oracle database, the modern Oracle, as we say, converged database, this multi-model environment where we have traditional relational data, we have JSON, we have XML, we have graph, we have spatial, and we have other forms of data that all coexist and live together within this converged database environment. So I'd really sort of encourage everyone to think about, as I describe spatial in particular, sort of I encourage everyone to really think about it in that sort of converged mindset. And that becomes really important because of the fact that we live together in the database with lots of other really powerful converged capabilities, and therefore we can sort of work together with them and play nicely with them, if you will, to really expand the reach of what we can do with spatial. So we are a data element in every Oracle database, but the focus here today is an autonomous database, and some of the really specific, really powerful advantages that you have with spatial in autonomous database. And as I mentioned, the value and the power in that is the fact that by being a sort of a core data element within this database environment, we can use location to ask questions and relate and bring together data that would otherwise sort of have no relationship to each other, if not for that sort of location relationship. And at the end of the day, that all belongs and really has its value in the business context. Again, whether this is sort of transactional sorts of scenarios where location is important in terms of where you're going to route people to service a bunch of service calls in a intelligent way, or in the analytics sort of historical sense where you're looking for location patterns and trends and where things tend to be clustered and concentrated together. So that's really what we're all about with spatial. So what does this sort of look like in a more practical sense? Well, it's really boils down to the fact that we store geospatial or location-based data natively in the database. And so that means points, for example, geocoded address locations, GPS locations, as you've got your Garmin device and you're going on a hike or a bike trip and you're positioning yourself so that you can replay where you were, those point locations, natural events like earthquakes. All these sorts of examples of point locations are stored natively, as are line type features. So that's like road center lines, utility lines, natural features like waterways, et cetera. And polygons or areas. So for example, administrative areas like provinces and counties and states and postal code areas, natural sort of natural hazard areas like flood zones, and sort of business defined areas like sales territories and reporting regions are all examples of polygons. And so points, lines, polygons, these geographic items, these elements, are all stored natively. Now, Oracle Spatial actually goes well beyond those sort of basic essential spatial data types into a whole wide array of sort of, I'll call them advanced or other sort of specialized spatial types. And I've listed a few of them here: 3D data, satellite imagery, et cetera. I'm going to really be focusing on these basic point, line, polygon types of examples. But these are all stored natively in the database in a native type and indexed with a native spatial index and a whole vast library of SQL operations that you can apply to ask the kind of questions that we see on the right about location and location relationships. And it's the ability to ask those questions natively in the database with SQL, which is really where the real sort of power comes from. The fact that you can do this all in the database and sort of it's standard SQL, so you can blend and mix these sorts of location relationship questions together with other sorts of traditional aspects of queries in the database and really just harness location and location relationships. So all the way down now to the kind of the bedrock level, if you will, of what it looks like to have and work with spatial data in Oracle database. Well, on the left, we have an example of just describing a table. And that table it's called parcels. And so this is a table that contains information about property boundaries, property areas. So that table has 4 columns: an identifier, a category, for example, is it residential or commercial or et cetera, some long other identifier, and then finally a column whose column name is geometry, but the important point is the data type. And in red, you can see that that data type is something called SDO_geometry. And that's simply the name of the native spatial type in Oracle database. And the name of the column, geometry in this case, is not really what's important. That could be, that column name could be any allowed name for a column in a table in Oracle. What's important is the data type. And what's also important is the fact that this is just a table. It's not a sort of some special kind of table that's kind of like a regular table, but is a spatial table. No, it's just a table that happens to have a column with a geometry data type. You could actually have multiple columns with geometries in a table that might store sort of that same shape at different resolutions and different degrees of detail. So it's just a column in a table. In that column is stored the geographic definition, the geometric definition of each of those properties. So it's a native data type within which we have all the coordinates that define the shape and the information that says that this is a polygon versus being a line or a point, etc. So it's a data type storing all the information necessary to define, in this case, a property area. What's important and what's really of value is what we see on the right, when you can start asking questions of that data. So I have this parcels table. I also have a table of predicted flood areas. And the question I want to ask is which of these properties, which of these parcels is within this predicted flood area. So you can see that the operator that I'm going to apply in SQL is this thing SDO_inside. And that inside is the, intuitively, I hope, the spatial relationship that we're asking about, which parcels are inside this flood area. You can see a trend starting here. We have this data type that says SDO geometry. We have this operator that's SDO inside. You're starting to see SDO showing up in some places, and that SDO is a common prefix that you'll see across the data type and the operators and the functions, and it'll be sort of something ubiquitous that you see, and that is a sort of an indicator that that data type, that operation is a spatial, is something spatial. But you can see down at the bottom that when we apply this operator, which is saying which of these properties is inside this flood area, what we're getting back is, of course, it's just a query result. It's a list of items that meet that query criteria. It's just a SQL query with a SQL predicate. We're not necessarily, in this case, we're not getting back a map, we're getting back a list of items. Now, of course, that list of items could be used to filter and highlight things on a map, but it's really just a traditional SQL statement that's using the spatial features. If you can write any basic SQL statement, then you know everything you need to know to be able to start asking location relationship questions. Okay, so that's sort of a basic first example of a spatial query in Oracle. Now, it turns out that the set of functions and operators and packages that we have for spatial in the database covers, I would say, almost, I really said, like any spatial location-based question that you could possibly have is going to be covered within the APIs that we have. So ultimately there's hundreds of operators and functions that cover what I would organize into a few, sort of organize them into some categories, just to help sort of narrow the search for the operation that you need to answer a specific type of question. So there are packages and operators that handle what I would call spatial search, or maybe you might consider it spatial filtering, where you want to identify which items satisfy some spatial relationship with some other items. And those are things like, for example, which are nearest. So we've got spatial data representing metro stations, and I want to know which are the nearest restaurants or coffee shops to each metro station. That's sort of a spatial search. And the example we just did with the properties and the flood area, that was a spatial search. We wanted to identify which items meet a sort of spatial relationship criteria. There's a whole package that covers every possible combination of spatial relationships to search for. There are spatial measurements. So we might want to know how far away are certain items from other items. What's the area of a given region, or the area of overlap between regions? And those are examples of where you're doing spatial, you're measuring things spatially. There's aggregations where we may have, say, a whole set of earthquakes or crime locations or financial transactions that are clustered together, and we want to aggregate by sort of defining what's the area that surrounds or encompasses that set of locations. That's an example of one of what are many these spatial aggregation type operations, and on and on and on. So there is a vast array of operations available to you, from the most basic sort of intuitive examples like the properties inside flood examples to much more sort of nuanced examples that help answer some really tough, what would be otherwise tough questions to answer about location relationships. So that's sort of generally what's in spatial, and that's actually in every Oracle database. And I should mention at this point that I'm focusing on spatial and database-driven development and autonomous database. Oracle Spatial is part of every Oracle database. It's a standard feature of every Oracle database. It's not an option or an add-on or anything that you license or acquire separately. It's just part of every Oracle database. And it's absolutely goes for autonomous database. Not only does that go for autonomous database, but there's actually some sort of specific things that are really autonomous database only. And this is one that I'm going to talk about now. That's a relatively new feature and is autonomous only, and I think is really exciting, and it's something that I hope people are gonna really jump into and take advantage of. So geocoding in general, in terms of working with spatial data, and in particular in terms of preparing spatial data, preparing data to be used in spatial analysis, it's common to start with addresses or place names. You're not generally handed over data that's already configured for spatial with the spatial data type and everything ready to go. You're oftentimes presented with data that refers to location in terms of addresses or place names, and you have to start with that and then get it into a spatial format where you can start to ask these spatial location-based questions. So geocoding is probably the most common example of that, and that's where you're taking addresses and place names and deriving what the coordinate, the location of that address or place name is, and then once you have the coordinate, then you can create the geometries, and away you go with all the other things that I've been talking about. So geocoding has actually been a capability of Oracle Spatial for a long time, but it has been and still is in a sort of an on-premises in your own Oracle database. It's a feature that requires you to assemble all of the underlying reference data that the geocoding engine uses to figure out where the streets are and where an address is along a street. Well, in autonomous database, that becomes much easier, because the geocoding capability is there without the requirement for you to acquire and configure any reference data at all. Instead, address geocoding in autonomous database takes advantage of a behind-the-scenes hosted service that Oracle maintains for Oracle applications to use, and there's several others that use that capability. Autonomous database has now joined that list, and so what that means is that in autonomous database, if you start with addresses, and this goes for sort of internationalized, and I've got a couple examples of the different ways that addresses are formatted in different parts of the world. If you start with addresses or place names, with SQL, you can derive or convert those into coordinates that you can then go forward and work with in spatial for location analysis and mapping. So that capability is provided as just another set of SQL functions within the Oracle Spatial SQL library. I've got here listed just, sort of for the sake of sort of hopefully making it a little more intuitive, just listing these are the names of the functions that perform that geocoding. There's a grant, a specific grant that's required for users that the admin user in Autonomous Database grants to a user that will be allowed to make these geocoding calls, and that's because this geocoding operation is reaching out to our hosted service. So we want to make sure that that's sort of governed by your admin user in Autonomous. So there's a grant that's performed, and then once that's performed, the user can do the geocoding. So I've got listed here a couple of resources in terms of a blog that gets into all of the detail with examples and then the documentation. This is Autonomous only. It's currently Autonomous shared only, and this will become something that's available on Autonomous dedicated. At present, it's Autonomous shared. Now, in addition to these resources for geocoding addresses with SQL, we also have a very quick sort of hands-on tutorial exercise for this. I noticed in the poll that Marcos showed at the beginning that it seems like quite a few people are familiar with Live Labs, which is great because we've got a bunch of spatial examples and resources in Live Labs, and this is one of them. So Live Labs, for the folks that haven't used Live Labs before, are these on-demand, hands-on, sort of self-paced workshops, tutorials that cover lots and lots of different areas across Oracle, lots and lots of database-related Live Labs, and we have a whole bunch of spatial ones. Within Live Labs, we have we have full-on workshops that will take you an hour or more, and you can sort of pick and choose parts of the workshops to do. But we also have something called sprints, which are very sort of atomic examples, very specific things. How do you do a specific operation? And we have one of those for geocoding using this API I've been describing. So I've got the link here, and I would encourage anyone that wants to just kick the tires, you could take a look and run some geocoding queries, and you'll see exactly how it works. Okay, so now that we've sort of seen the baseline of the spatial data natively and asking location questions with SQL, I want to turn a little bit to the way, from a database developer perspective, how spatial works together with other features of Autonomous Database and Oracle Database in general. And the first of those is the way that spatial works together with the native JSON features of the database. So this is sort of a prime example of that message I described earlier, with us spatial being one of many converged features. And because we're part of the same database, we can work together. When it comes to database-driven development, JSON is obviously huge because JSON provides so much agility when it comes to data that is whose schema is interpreted on read instead of write, so that you can have data that is sort of not necessarily adhering to a fixed data structure, and JSON is great for handling that. So it's obviously hugely popular with developers, and it turns out that it's also, in particular, really popular with anyone working in the spatial realm, and for sure anyone that's working with mapping libraries, client libraries, to put interactive maps into web applications. There is a JSON format for spatial data that is sort of a standard GeoJSON, and it's a sort of industry-wide recognized format for exchanging spatial data in JSON format. So the fact that we have all this native JSON handling capability in the database that spatial can work together with really puts us in a great position to provide sort of a real seamless experience with developers that want to work with JSON and take advantage of all these spatial capabilities I've been describing. So a couple examples of where that comes into focus are, first of all, the ability to store data natively as JSON in the database. So just our in-database JSON handling capability, and to be able to use the JSON functions that we have to be able to have data stored in JSON, but be read and operated on as if that data was stored in a traditional table with our native spatial data type. So the JSON sort of functions of the database do that in general. It's not a spatial feature, it's just an in-database JSON feature. But we as sort of a peer, as sitting alongside these JSON features, we're sort of built into those functions, so that if JSON in the database happens to include GeoJSON, then that JSON can be returned. We can return our native data type from a query. So that means that you can enjoy the benefits of this agile management of JSON data with the schema on read, and if it includes GeoJSON, you can apply those spatial functions and spatial operators and spatially index it as if it was stored in a traditional table. That's, whether even when it's not geometry, the big value of JSON in the database, that's a big part of it, and we just are able to participate and take advantage of that. Another example of us of spatial and JSON working nicely together in a database is the fact that we within our spatial functions and spatial SQL API have SQL functions and methods on our geometry type that allow you to just switch back and forth between our native data type representation of a geometry and a GeoJSON representation of a geometry. So any query that you write, anything that would return JSON, you can apply a function or a method and have that result just seamlessly returned as GeoJSON in order to hand off to a developer that's going to consume it. And from the other direction, any input to a spatial query that's coming in JSON or GeoJSON format can be seamlessly transformed to our native geometry. So the bottom line is that it's a very fluid integration, or very fluid transition to be able to work back and forth between working with JSON and working with our native spatial format. To step back a little bit from the database or developer perspective and look more broadly, we've talked about how in Autonomous Database we have the spatial capabilities, and so far we've focused on working with, if you look at the top left, with SQL, and then by extension PL SQL, to be able to take advantage of these spatial features. Well, also on the upper left, we see several other examples of where database-driven application development, where there is a variety of opportunities and approaches to taking advantage of spatial and autonomous database. So beyond just the SQL and PL SQL, we're going to talk about Application Express, which is database-driven web application development environment, and Oracle REST Data Services, database-driven REST enabling, essentially, the Oracle database. We'll talk about those a little bit more in a moment. I want to mention that you see on the upper left, there's something called Oracle Spatial Map Viz component, map visualization component. Folks may be familiar with its historical name, which was Oracle Map Viewer, and it's now referred to, now called Oracle Spatial Map Visualization Component. That's actually a mid-tier server component. It is provided at no extra cost with the database. Anyone working with database, with Autonomous Database, has access to this. And it's a mid-tier server component that provides sort of a spatial data server and a spatial background map tile service, so that applications can have custom configured, custom designed background maps. I'm not going to get too into that component in this presentation, but I just wanted to make people aware of the fact that that is one of the developer resources that you have available to you that comes along with Oracle Spatial. In addition to that, and I'm also not going to get too into this in the rest of this session, but there is a native Java API for Oracle Spatial as well. So people not working with SQL or PL SQL, people that are just going to work with native Java development, Java client applications, You do have access to a native Java API for handling and working with our spatial data type and the core set of spatial operations. I will talk a little bit about Python and spatial in a few minutes. That's all from the database developer perspective, sort of Oracle tooling. Underneath that, you see Oracle Spatial Studio, which is our self-service or no-code tool for working with the spatial features of the database. And there's actually some really powerful features of Spatial Studio that are very useful to developers. So it's actually not just for like non-coders and purely non-technical users. It's actually a resource for sort of more technical developers as well, as I'll describe in a few moments. Over on the right is sort of a representation really of the whole geospatial software industry and the fact that this whole industry supports Oracle Spatial as a spatial data management platform underneath their tools and technologies and developer kits, etc. So all of the major GIS or Geographic Information System products out there, ESRI is very popular, commercial GIS products. QGIS is very, very popular, open source products, as is Hexagon and others in around the world. All those GIS tools, as well as geospatial data integration, or in other words, the tools that allow you to transform spatial data between formats and commercial data providers. This whole industry does and has for many, many years sort of universally supported Oracle Spatial as a sort of a supported data management system for spatial data. What that means is that anyone using these tools are able to take advantage of the capabilities of the database for managing, scaling, securing spatial data without having to change the way that they use their tools, because their tools support that platform natively. So I want to get into a few of the items on the left in a little bit more detail now. And I want to start with Spatial Studio. So just to reiterate, Spatial Studio it's a web application. It's a sort of a web tool. Its purpose is to allow you to access and load and prepare spatial data, to be able to drag and drop and visualize it on interactive maps, and then start to ask location-based questions, basically those sorts of spatial queries that I talked about earlier, but perform them as just a drag and drop menu-driven sort of no-code. Spatial Studio is one of a series of mid-tier components that are just provided at no extra cost with the database. That map visualization component server I talked about, that was another one of those no extra cost components. Oracle Spatial Studio is on the Oracle Cloud Marketplace. So you go to the Oracle Cloud Marketplace, and there is a free, it's one of the free apps. The app is free. It can actually run on the on free tier compute. You can obviously deploy it to a more powerful compute depending on your workload, but the application itself is free. It's also an application that if you have a license for or a cloud plan for any Oracle database, you can also deploy Spatial Studio yourself. It's just a standard Java application that you can deploy to your WebLogic server, to Tomcat, and it's also available as a pre-built app in a Jetty, which is another open source Java server. It's provided as what we call a quick start, pre-configured, pre-deployed zip file. You unzip it and you run it, and you could run it on your laptop or on a sandbox in your own data center. But it really focus on running it from the cloud marketplace. In particular, if you're working with autonomous database, it just makes perfect sense to run Spatial Studio, to deploy it from the cloud marketplace. So it obviously has a lot of capabilities that are great for non-technical users, but for developers, for folks that are interested in database-driven development and autonomous database with Spatial, a couple of things that Spatial Studio allows you to do is, number one, with drag and drop, create spatial queries, essentially, have Spatial Studio create the queries for you. You can look at the results, but then you can look behind the scenes in Spatial Studio and see what type of spatial query was built and actually grab and copy that query and then work with it as a start point. And there's also programmatic resources in terms of the underlying REST API and endpoints that Spatial Studio provides. So I want to actually hop over for just a moment and show an example, quick example of what this looks like. So here we have Spatial Studio. This is Spatial Studio running in the Oracle Cloud, deployed from the Oracle Cloud Marketplace. When you begin with Spatial Studio, I haven't created any projects yet. You have some little videos to watch and little explanation of what your work path is going to look like. But fundamentally in Spatial Studio, what you do is you connect to databases, and in particular, we connect to one or more autonomous databases, or traditional databases. But I've got a connection to an autonomous database, and then you create data sets which are simply pointers to the data in those databases. So to create a data set, I could upload data from files. It'll load it to the database and then give me a reference to that data. I can also point to data that's already in the database. And that's what I've already done here. And in this particular case, I have some customer data set. And that data set simply includes a bunch of customer information, including addresses. But there's no geometry. It hasn't been configured for spatial yet. So just like we saw the geocoding SQL API and autonomous database, well, Spatial Studio also provides the ability to do geocoding, but in this case through a GUI, using the same service behind the scenes. But here Spatial Studio has looked into the data, figured out which columns to use, where the data, which columns in the data has the appropriate address information, and then I just apply. So just same sort of operation that one could do with SQL and autonomous database, and Spatial Studio is going to let us do it through a GUI. So it's running through these data, and as soon as it's done, what we're going to see is that the data will now have a new column that's been added to it, and that new column is going to be one of these native SDO geometry columns that's going to have the point locations for each of these addresses. So that's done now. This thing is turned into a pin instead of a little table icon. And we see that where there was no geometry before, there is a geometry now. And I could take this now in Spatial Studio and create a project from it, which is sort of our working area where we can drag and drop and look at our data. Now these are the geocoded locations for these customers. So that's a little bit of data prep, and we could start to work with that data. I actually have a couple of other little pieces of data here, a flood area and a set of buildings, to serve it as an example for asking a spatial question in Spatial Studio. So I'm going to drag and drop this flood area, and I'm going to change the way it looks quickly to make it look a little bit more flood-like. So now we have a flood area, and I'll drop these buildings on top of it. Now we have these buildings in this flood area, and the question I want to ask is which of these buildings is not necessarily contained inside the flood area, but touches the flood area in any way. So perhaps it's completely contained, but perhaps it's also just sort of partially overlapping. I'm interested in all of those cases. So to ask that question, if I knew SQL, I could go behind the scenes and do the SQL. But what I want to do is use this tool to do it. So I'm just going to change my background to subdue the background a little and make my data pop out. And so I'm going to say create analysis. The analysis I want to create is I want to know which items in my buildings have any spatial interaction with the flood area whatsoever. So I'll say buildings contacting flood. So I want to search through my buildings data to find out which have any spatial interaction with this flood shape. And that's all I have to do. And now I have a result here that I could drag and drop in. And then when I do that, I can highlight it in any way that I choose. So I'm going to choose to highlight it by outlining the ones in red that have any spatial relationship. And you can see it's finding the ones that are inside, that overlap, what have you. So that's self-service. But what's cool from a developer perspective is that if I look at this analysis that I just performed, I have the SQL here. And so, you can see that in that SQL is this SDO any interact, and that SDO is the thing I said you're going to see in all the spatial operations. Any interact means any interaction, any spatial interaction at all. So you could take the SQL, and there's your start point for a spatial query. And we also have a GeoJSON endpoint. So if I copy that endpoint that we just saw, and I invoke it, and I could invoke it from any REST client. I'm just going to use my browser to display the results. This is the same set of results. These are the buildings that touch that flood area, but returned as GeoJSON that any client could work with programmatically. So you could structure your analyses in Spatial Studio and work with them programmatically and consume them with any standard client. So that's a quick bit of Spatial Studio, and that's sort of the first example of really like self-service for non-coders, but also useful for developers. A bunch of other sort of features and capabilities of Autonomous Database have additional like tremendous value for developers, and the first of those is Oracle REST Data Services. So just like Spatial Studio is no extra cost with the database, well, same thing for Oracle REST Data Services. Oracle REST Data Services simply REST enables your database, your Oracle database. So that means your tables, views, procedures, functions, ad hoc, SQL, anything that returns a resultant content from the database, you can REST enable. In other words, create a REST API that allows access to that database content. Now, unlike Spatial Studio, which is currently on the cloud marketplace, but it is an application that you install from the cloud marketplace, and then you manage that application. Oracle REST Data Services with Autonomous Database is a managed service. It's one of the Autonomous Database tools, meaning it's automatically there for you with Autonomous Database, and it's a managed service, so it's updated, it's patched, Oracle maintains that application. Of course, it's also something that you could, like Spatial Studio, deploy yourself to your own Tomcat or WebLogic server, but in the context of Autonomous, it's just automatically there as a managed service. So that's Oracle REST Data Services in general. And because JSON and GeoJSON is so powerful, so useful in general, for spatial and mapping related applications, this is a great fit. It means that the kinds of queries and the source, the content that you're delivering through REST APIs can be spatial and location based. So that can mean everything from things like, I'll call it like a location-based API that just lets you ask questions and get back results. Which of my properties are within a certain distance of a predicted storm path? And all I want to get back is a list. I don't necessarily need a map. I just want to know who to notify. Well, Oracle REST Data Services can just do exactly that because the query behind the API can be one of these spatial queries. You can also use Oracle REST Data Services to return actual spatial content, GeoJSON, the shapes themselves that can be put onto a map. So Oracle REST Data Services is a great fit with Spatial, and because it's a managed service and has a whole GUI for defining and creating these APIs within Autonomous Database, within database actions, which is sort of the whole web UI area for all the tools that allow you to work with data, getting data loaded and configured, and in this case, provisioned and configured as REST APIs. Spatial is a perfect fit. So here's an example of a Oracle REST Data Services creating a REST API that allows you to identify earthquakes earthquakes above some minimum magnitude within a distance of a coordinate. So you're basically just going to ask the question, I want to know which earthquakes greater than magnitude 4 happened within 50 miles of this location. And so with Oracle REST Data Services, you define the signature of your API, the URI, and then you define what we call the handler behind that endpoint, which is simply what's the query, what's the database operation that's going to return the result. You see on the upper left that handler is just simply a query, a SQL query using one of these spatial operations. So really, it's it's nothing different or special from the Oracle REST data services perspective. It's just the fact that since we are a part of the database, that these handlers for a REST API can just flex all the power of what the spatial capabilities are in the database. So here's an example of a proximity query returning results for a REST API. And in this case, it's just returning it in the JSON, the sort of the standard off-the-shelf JSON format that Oracle REST Data Services provides. However, Oracle REST Data Services also allows you to fully configure and tailor what the JSON format is that you return. So in this case, I've got the same query basically, but instead of returning it in a vanilla Oracle REST Data Services JSON format, I'm returning it in GeoJSON format, this very specific sort of industry accepted format for spatial data, meaning I create a REST API with Oracle REST Data Services that any standard mapping client can consume and put on a map. Another example of spatial and autonomous database tools working really well together is Oracle Application Express. So yet another example of sort of a free tool, a free component that just comes with Oracle Database. And in the case of autonomous database, once again, it's one of the autonomous database tools. It's a managed service. It's just you have autonomous database, you have access, you have APEX, Application Express configured and ready to use and updated and maintained by Oracle behind the scenes. So Application Express itself, just like Oracle REST Data Services, is there to REST enable content in the database. Well, Application Express is there to allow database developers, people that are sort of somewhat familiar and comfortable with just working with tables and SQL queries and just basic database elements, allowing those types of database people to sort of instantly become enterprise web application developers, because it sort of Application Express assumes some basic understanding of how to write a query and work with the database. It does not assume that you are a professional web developer. It sort of takes care of those aspects of building the application for you. So it's perfect. It's really there for the persona of someone that's sort of a database-centric developer, but wants to create powerful enterprise-ready web applications. I should say both for desktop and mobile devices. APEX is extremely popular. There's a huge sort of global community of APEX developers. There are APEX meetups. There's APEX conferences. This is something really worth paying attention to, just because of how real big it is. And there's a couple of links here I have to sites that you can go to and sort of see what this community looks like and what people are doing with Application Express. So just to take a little bit of a closer look at what it looks like and what it means to work together, use spatial with APEX. First of all, as I mentioned, you see here that in Application Express, you have this sort of drag and drop canvas where you lay out the content on your web pages and the various controls that you have on the page, and then way things navigate around through the application. But underneath it all, there are just database objects, tables, views, queries. Well, here we see an example of sort of a canvas on the left that defines a page, and the query that defines the content in that page. And that query is just a within distance, a proximity query. In this case, it's a query that asks for every airport, how many other airports are there within a certain distance of it. So just an example of a proximity query, not returning a map, just returning a sort of a tabular list. Well, that's nothing special for APEX, and that's sort of the beauty here, that you incorporate these spatial operations into any query that you're using to deliver results in Application Express, whether you're going to show it as a table or a chart, sometimes a map. you can take full advantage of using spatial functions for spatial search, spatial relationships, measurements, etc., and include them in your APEX application. So while maps are not always key, they are often really, really helpful. And maps now are a first-class visualization type in Application Express. It used to be that in Application Express, it was possible to include maps and you do a little bit of scripting, put a little JavaScript in here, there, you could make it work. Well, now for the last year plus, maps are a sort of a first-class visualization within Application Express. So you can see here on the left, we have our same sort of canvas for a page in Application Express. And on the bottom are these different sorts of visualizations that you could drag and drop onto your page, whether it's a table or a chart or some other sort of widget. And you can see that there is now a map. And that map that you drag into your page is then fed by, again, this could be a query, an explicit query or some table or view in the database. The key thing here is that that map can be configured such that it is using this SDO geometry, this native data type, as the source for what's in the map. And that's what you can see in the red box. It's sort of on the upper middle part of that canvas, where we're saying that we're dragging a map onto the screen. And the data that's going to feed that map is coming from a column called geometry, and the data type is SDO geometry. So this is all first-class stuff in Application Express. There is a showcase application, a free application in the APEX sample apps that you can download and install in your own APEX environment that shows lots of really cool examples of working with spatial in Application Express. We actually have a live lab specifically on this that I'll show you how to find in a moment. The last item I just wanted to mention was Python. And so we've talked about database developers, database development. Well, there's also the whole realm of machine learning and data science and that whole realm of development. And Spatial is a great fit here because of the fact that, well, first of all, we Oracle have this Python Oracle DB driver, basically this module that provides robust access from Python to Oracle database, in particular Oracle Autonomous Database, so that from Python you can connect to Autonomous Database and work with Autonomous Database and take advantage of all kinds of advanced features of the database without having to do a bunch of extra coding, because this driver understands things like object types and character and binary large objects and JSON types and cursors coming back from queries. All these things that this Python Oracle DB module allows you to do makes it easy to tap into Oracle and things like spatial data, get them into Python where you can mix and blend that data with specialized libraries to do things like predictions and other sorts of classifications and detect trends and things that are part of specialized libraries, but at the same time have the data scaled and secured within the database and distilled down to where you bring appropriate subsets and features that you've extracted into Python, mix that data and apply it with the requisite specialized libraries, and then results can be fed back into Autonomous Database, and you continue with the work stream. So Python, Spatial, and Autonomous Database work really great together, and we're actually working on a new live labs that's going to involve exactly that. Just to conclude with some resources, this product portal is sort of the entry point for all things spatial with Oracle Database. We have an ongoing blog with a variety of articles talking about what's coming, what's just come out, what's new, obviously documentation, a YouTube channel with lots of replays of webinars like this, and then live labs. And I just want to end on that because there's some really important ones. Well, we talked about the geocoding example. We have live labs. If you go to the live labs sort of homepage and search for spatial, you'll see live labs, just very basic work with spatial data in Autonomous Database. You'll also see Spatial and APEX and a whole live lab just on getting all that going and doing some examples there and others. So I encourage everyone to take a look at the live labs. And with that, I'm going to turn it back to Marcos and see if there's any remaining questions.
Yeah, thank you very much. That was excellent. Thank you very much. It was really good, David. We have one question. Go ahead.
Yep. Yeah, so the question here, can you speak about geolocation visualization in Oracle Analytics Cloud? Are the SDO functions on SDO geometry supported in OAC? And it looks like there are answers being typed in right now, and I guess I can sort of verbally answer at the same time Hans is answering. So the answer to the answer to the question, sort of starting with the second part and then to the first part, are the SDO functions on SDO geometry supported in OAC? OAC does not yet natively support the SDO geometry data type. However, any client, whether it's, well, I say client, meaning any tool, any product, any technology that's talking to the database, I'll call that a client. Any client that can issue a SQL statement directly to the underlying database can use these SDO functions. And OAC and other products that have the ability to just ship a query to an underlying database can take advantage of those functions. So one example would be in OAC, when you create a data set in OAC, of course, you can pick one of your connections and navigate to a item, a table in whatever flavor of database you're connected to. But another option in OAC for creating a data set is to issue a direct query, a SQL query that you write in OAC, but the query is just shipped right to the underlying database, and then the database gives back the results. That can absolutely be an SDO function. So in OAC, you could create a data set that would be, coffee shops, coffee shops within distance of metro stop. And you just define it with a SQL query. OAC doesn't really know or care about what this SDO function is because it's just sending the query to Oracle database. So, that hopefully, clarifies, I would think, probably the two parts of the question. Does OAC support today the native SDO geometry type natively within OAC? No. Can you ship a query? Can OAC invoke a query using SDO functions in Oracle Autonomous Database? Yes.
And it can use lat long directly.
All right.
You pointed at lat long columns.
Oh, that's a good point also. Yeah. So if you get lat long, so absolutely. Yeah. So I won't get into it past that, but the kind of the queries that you run, even if it's an SDO query, if you're going to do a query from OAC and that query is looking for coffee shops near a metro station, when you return that query could return the longitude and latitude. And that, like Giant was just saying, the longitude and latitude coming back from that SDO query, OAC can absolutely put that right on the map. So there's a lot of dials to turn and a lot of flexibility in terms of the way
you
that
can
these
also
things
just do something simple, right? You've got store locations with a lat long. You can show year-to-date sales, year-over-year sales, all that, drill up, drill down. Don't need to do anything with SDO geometry. It just can use lat long for visualization and doing the OAC, showing the metrics, the KPIs.
Excellent. All right, excellent. Yeah, that's great. Thank you, Giant. So for now, I think we're done with questions. Guys, if you have any more questions, please make sure to type them in the Q&A. Thank you again, David, for joining us today. These again, I'll leave you guys with some of the links for the autonomous database. I'm gonna post these links and the spatial links as well with the recording when you guys see the recording. I think that's it. So final thoughts, guys. Make sure to come back to the bit.ly/ADB Learning Lounge. There's where you're going to see the recordings, the links to the resources for the sessions, and the next sessions coming up. Okay. And speaking of which, we got so we have upcoming sessions for multi-cloud integration. and the hands-on workshop on data sharing. Okay, so I'll leave the channel open. I'll leave the call open. If you guys have any more questions, you can just type them in. We're here for a few more minutes. But then thank you, David, again. Thank you, Giant. Thank you, Hans, and thank you, Keith, for joining us today. I appreciate you guys.
Thank you, Marcus.
Thank you very much.